Welcome back. We'll be starting a new module covering isotopes, atomic masses, and moles. In this video, we will be discussing isotopes. You already learned the modern view of the atom consists of a densely positively charged nucleus containing protons and neutrons surrounded by a negatively charged cloud of electrons. You also learned that each element is distinguished by the number of protons contained in its nucleus. For example, all atoms containing 6 protons are carbon atoms. While all neutral carbon atoms contain 6 protons and 6 electrons, they may contain differing numbers of neutrons. Atoms of the same element with different numbers of neutrons are called isotopes. Isotopes are differentiated using isotopic symbols. The isotopic symbol consists of the elemental symbol, the atomic number, which is also the number of protons in the nucleus, and the mass number. This is the total number of protons and neutrons within the nucleus. There are 2 stable isotopes of carbon. One has 6 neutrons, the other contains 7 neutrons. Since all carbon atoms contain 6 protons, isotopes are identified using their mass number. Therefore, the 2 stable isotopes of carbon are called carbon-12 and carbon-13. Every element up to atomic number 83 contains at least one stable isotope. Using our isotopic symbol, we can rewrite this as the carbon symbol C, atomic number 6 and mass number 12, and for carbon-13, also atomic carbon C with its 6 protons and its mass number 13. Isotopic symbols can also be used for ions. For example, the 2 stable chloride ions are chloride 35 and chloride 37. They are written the same way as neutral isotopes, with the exception that their ionic charge is written in the upper right-hand corner, which is usually done for any ions. So for chloride 35, Cl for chlorine's atomic symbol. It's the chloride ion, so it has a -1 charge. Periodic table tells us it has an atomic number of 17, and then the isotopic name 35. We can do the same thing for chloride 37. When given the isotopic symbol or name, the number of each subatomic particle can be determined. If we go back to chloride 37, we note that it has 17 protons from its atomic number. We can determine it has 18 electrons due to its overall ionic charge. And we can determine the number of neutrons by taking the mass number and subtracting the atomic number, giving chloride 37 20 neutrons. So, let's look at a couple of examples. How many of each subatomic particle does silver 109 contain? Remember, the symbol for silver is Ag. According to the periodic table, silver has an atomic number of 47. This tells us that it has 47 protons. Since this is not an ion and it is a neutral isotope, it must also contain an equal number of electrons, 47. Finally, the mass number, the sum of protons and neutrons, can determine our number of neutrons. So 109 minus 47, we get a total number of neutrons of 62. We can also work in the opposite direction and determine the isotope from the number of protons, neutrons, and electrons. For example, what isotope contains 24 protons, 18 electrons, and 28 neutrons? Well, the atomic number is also the number of protons. So according to the periodic table, we are dealing with element Cr, chromium. We can determine the mass number by adding the number of protons and the number of neutrons together for a total of 52. And we notice that the number of protons does not match the number of electrons, therefore we must have some ion. In order to determine the ionic charge, we take the number of protons and subtract the number of electrons to get an overall ionic charge of 6+.